Alright, we're going to talk about area under a curve. If y is equal to f of x is non-negative and integrable over a closed interval from a to b, then the area of the curve from a to b is given by, and you've seen this before, this is when I talked about the area. Here's our starting point, here's our ending point, and so what is the sum of our, we've been talking about the sum of our trapezoids, or in this case we're just going to say what is the total area underneath a curve. The region bounded by the x-axis and the vertical lines from A to B, and this region should be always positive. Now remember, I told you if you're talking about area beneath the x-axis, then we're talking about a negative area. However, a definite integral of integrable s can represent other fields, so like we can talk about profit, loss, water consumption, exit entrance into a store. And so when we're talking about these types of situations, these could be positive or negative. And so if you want to talk about the end of the curve with a negative area, we're talking about the area from A to B, the area above the x-axis minus the area below the x-axis. So that's why we have, when it's negative, we're going to be subtracting. Alright, number one, set up a definite integral that yields the area of the region denoted by f of x is equal to the square root of 9 minus x squared, and we're going to solve our integral. So our first step is, I just want to help you guys figure out what this picture looks like. So if f of x is y, so if y is equal to the square root of 9 minus x squared, and if I square both sides, I get y squared is equal to 9 minus x squared. Add x to both sides, I get x squared plus y squared is equal to 9. And this is a circle. And so what I gave you is a semicircle that's on the positive end. It's centered around the origin, and the radius is 3. There we go. So there is my semicircle. And so if we want to find the area in the curve, we have to do our sum. So we're talking about the sum of the area. We're starting at -3 because that's where my semicircle begins, and we're ending at positive. That's where my semicircle ends. And then here inside we're going to do our function. So 9 minus x squared. If you want to think about in terms of trapezoids or rectangles, that's going to be my height. And up to this point, I've been telling you the width. We've been talking about width being equal to delta x. Well, if you want to look at delta, delta begins with d. And so when we talk about integral, we're going to talk about dx. That means the width. So right now I have the height. That's the square root of 9 minus x squared, and now we need to multiply by the width, and we're going to call that dx. And at this point, you don't know how to do this algebraically, but you do know how to use this in geometry, so let's be a little bit creative. I have a semicircle, yes, and so the area of a semicircle is equal to 1/2 pi r squared. So pi, but my r is equal to 3, so it'll be 3 squared. If I simplify that, I'm going to get 9 pi divided by 2, and that is the true area. That's not the approximation, that is the true area underneath the curve. Number 2, in the linear piecewise function f of f below, f says the given points is defined from -2 to 3. So again, -2 will be my lower bound, 3 is going to be my upper bound. That's why it has -2 on the bottom, 3 is on top. We don't really know the function's value because I gave you a picture, but we can find the area underneath the curve. And so I have given you a piecewise function with a bunch of different types of shapes. And if you notice, I have a shape here called a triangle. And so we can find the area of a triangle. It's going to be 1/2 base times height. So my base is 1, 2, 3, And we want to figure out what is this, and it looks like a half, and I can verify it because my slope is down 2 right 1, so it's -2. So if my slope is -2, if I half everything, because we're only going down 1, if I half everything, then it means it's going to be -1 over 0.5. And so if I go down 1, that means I have to go over 0.5. So this point actually really is 1.5. So I can find, so my base is 1, 2, 3, 3.5. My height is 3. And so if I want to find my area, it's 1/2 my base, 3.5, times my height, which is 3. Now let's look at this guy right here. He is a square. And I hope that you can just go ahead and guess he's going to unit of 1 because it's a 1 by 1. So his area is 1. My last is this really small triangle here. His base is 0.5. We knew that from previous with the red. And its height is 1. Oops. So his area is 1/2 my base, 0.5, times my height, which is 1. And then I have finally my other area, which was a 1 by 1. Now if I was going to sum all my areas, then I would have the total area underneath the curve. Alright, my red area, this is going to be given 5.25. My blue area is 0.25. And my green area is 1. So if I sum all these, I'm going to get, what, 650? I think. Let me see here, 25, 25, that'll be 550 plus 1, 650. Yep. And that is the total area underneath the curve.